All right, now we're going to talk about how to solve equations with radicals in them. So I wrote the steps over here. Here we go, down here in purple. So you can follow along in this example that's already written out, and then we'll continue to follow along as we go through new examples. So first step, if you've got something like this guy, so square root of 4x plus 1 equals 3. First step is make sure that your radical is isolated, your square root, or if you have a cube root or whatever, make sure it's isolated. And in this case it is, but like when we get down to number 4, we'll need to do that isolate step. So we've got that plus 1 that we need to move over to the other side. But for this first example up here, our radical is already isolated. So next up, all we do is square both sides. So we would square both sides, which gets us down here. And if we square a square root, the radicand, the thing under the square root sign, gets pulled out. So we just end up with 4x plus 1 on the left, and then 3 squared on the right-hand side is 9. And then we just solve from there. So 4x plus 1 equals 9, subtract 1 from both sides, which gives us 8 on the right-hand side. Divide both sides by 4, so we end up with x equals 2. So we squared both sides, we solved the equation, and then our final step is mandatory. This isn't where we're just like, oh, if you have extra time, check it if you feel like it. This is a mandatory check, and you need to check your solution in the original equation. So if you want to check your solution in the original equation, here's what it would look like. The original equation was square root of 4x plus 1 equals 3. So what I'm going to do is I'm going to replace x. I'm going to erase that and replace x with my proposed solution, which is 2. Okay. So the square root of 4 times 2 plus 1, I would simplify that as the square root of 8 plus 1, which is the square root of 9. And the square root of 9 does equal 3. So at this point where it says square root of 9 equals 3, I know that my solution checks out. Just to show you a quick counterexample, let's suppose we had the original equation 4x plus 1 equals negative 3. And it's already isolated, the square root's isolated. I square both sides, great. I get 4x plus 1 equals positive 9. I would solve and I would still get x equals 2. And then when I go to check this in the original equation, I should be seeing that 4 times 2 plus 1 equals negative 3. And at this point, I have the statement that the square root of 9 equals negative 3, which of course is a false statement. So in this case, my solution doesn't work, and I would say there's no solution to the equation. Okay, so that's why the check is important. All right, so taking a look at number 4, we're asked to solve and then check our equation, of course. Sometimes the instructions will say check, and if you see check in instructions, then it's definitely a mandatory check. Even if it doesn't say check in the instructions, you definitely need to check your solution at the end of this. All right, so in number 4, our first step is to isolate that square root. So we do have to subtract minus 1 from both sides here. Boom, boom. So that gives me square root of x minus 4 equals 5 minus 1, which is 4. And now that the square root is isolated, now we can square both sides. So I get x minus 4 equals 4 squared, which is 16. And then I'll add 4 to both sides, solve and get x equals 20. Fantastic. And then for my check, let's check it over here to the side. So for my original equation, it should be the case that the square root of 20 minus 4 and then plus 1 equals 5. So that's the square root of 16 plus 1 equals 5. And then we know that the square root of 16 is 4. So at this point we have the statement 4 plus 1 equals 5, which we know is a true statement. So that means our solution of 20 checks out. And before we go on to number 5, I just want to point out this over here. So I wrote really big next to it, don't do this, so you shouldn't do this. The reason that step 1 is really important, isolating the square root, a lot of people would look at that example in number 4 and they would just start squaring. So if we wanted to square, so going down to this line, if we wanted to square the left side of that equation, square root of x minus 4 plus 1, if we want to square that, that's actually a FOIL because of this plus sign, right? We've got the radical plus a constant. So we're really foiling here. So if we FOIL it out, we'll end up with x minus 4 plus 2 times the square root of x minus 4 plus 1 equals 5 squared on the right, which is 25. But obviously we haven't made any progress there, right? We've actually made it a lot more complicated and a lot worse. So I just want to mention that you can't square until you isolate that square root. A lot of people mistakenly, sorry, that should be minus. A lot of people mistakenly think that square root of x minus 4 plus 1 squared would equal x minus 4 and then plus 1 squared, which is 1, but that's totally incorrect. So just be aware that you can't do that. I promise you your first step is to isolate the square root. Okay, so there's your little PSA for the day. All right, so number 5, the square root's already isolated, so I'll go ahead and square both sides. So 2x plus 5. I want to square that. And then on the right-hand side, if I square x minus 5, that's actually going to be a FOIL problem, right? X minus 5 times x minus 5 is equivalent to x minus 5 squared. So on the left, I get 2x plus 5. And on the right, I'm going to need to FOIL to get x squared minus 5x minus 5x, which adds up to minus 10x. And then negative 5 times negative 5 is plus 25. All right, so we've gotten rid of the radical. That's great. And now we need to solve what's left. And notice that we have this x squared term. So when you have an x squared that's not going to get canceled out, or just, there's just one x squared term, so it's going to stay in there. That tells me that we have a quadratic equation. So I would start off by trying to set this equation equal to 0 and then factor to solve. So I usually like to keep the coefficient of x squared positive. So I would subtract 2x from both sides and then subtract 5 from both sides. So this gives me x squared minus 12x and then plus 20. And on the right-hand side equals 0. And then factoring on the left-hand side gives me x minus 2 times x minus 10 equals 0. Set each factor equal to 0, and this would give me two potential solutions, x equals positive 2 or x equals positive 10. Okay. So we need to check both of these solutions. So first, I'll check x equals 2. And remember that we're doing this check on our original equation, so before we squared anything, before we made any changes to it. So checking x equals 2, I have the square root of 2 times 2 plus 5, which should equal 2 minus 5. This is the square root of 4 plus 5, which should equal negative 3. And then we get to the step where it says square root of 9 equals negative 3. So at that point, we know we have a dud, right? Because square root of 9 should equal positive 3, not negative 3. So we have to kick out x equals 2. That's not a solution. And now I'll go through this process one more time to check our second proposed solution. Check x equals 10. And checking x equals 10, I'll have 2 times 10 plus 5 under the square root equals 10 minus 5. This would be the square root of 25 equals 5, and that's a true statement. So x equals 10 is our one solution. We kick out x equals 2. All right, and then finally, let's take a look at number 6. We need to first isolate that square root. So I'm going to add 1 to both sides. Gives me square root of x plus 3 equals x plus 1. So my square root is isolated. And now that it's isolated, I'll go ahead and square both sides, which means x plus 1 squared is the same as foiling x plus 1 times x plus 1. So I have x plus 3 equals x squared plus 1x plus 1x is plus 2x, and then plus 1 foiling over there. And once again, I have that x squared, so I'm going to zero out. one side of the equation. So that gives me x squared plus 2x minus x is just plus x or plus 1x. And then 1 minus 3 gives me negative 2, and set that equal to 0. And then when I factor, x plus 2 times x minus 1 equals 0. Set each factor equal to 0 to get my two proposed solutions. All right, so I've got my two proposed solutions, x equals negative 2 and x equals positive 1, and let's go ahead and check these. So first I'll check x equals negative 2, and I want to do this in my equation before I touched anything, so with that original equation. So I've got square root of negative 2 plus 3, and then minus 1 equals negative 2. So this is the square root of positive 1 minus 1 equals negative 2, which would be 1 minus 1 equals negative 2. And at this point, I can see that the left side isn't going to match the right side. So that check doesn't work. We kick out x equals negative 2. And I'll go ahead and do a second check with x equals 1. 1 plus 3 under the square root, and then minus 1 should equal 1. Square root of 4 minus 1 should equal 1. 2 minus 1 equals 1. And we can see we have a winner. So we have one solution, which is x equals 1.